Welcome to this lesson. This presentation was developed by Mark Durand, Crystal Lepers, Mina Kashawabra, and Bev Patterson, with credits to Narendra Singh, Tom Kiedrazinski, and Hazel Clothier. This module will teach them information products, data dissemination and use, Part 2. Slide 2. These are our learning objectives. We are going to recognize tables, graphs, and maps as a form of data dissemination. Slide 3. This session looks at the information feedback side of the DDM loop. We will talk about information products and data dissemination. Slide 4. Tables are useful tools for presenting data and results in a clear, organized and understandable way. Table is an alternative to long lists of numbers in text which would be difficult for readers to follow. You can use rule of thumb: for up to 3 to 4 numbers, put in text; more than 4, make a table. Slide 5. What would you do, table or text? Diarrhea was the most common symptom among cases, 92%, followed by nausea, 84%, and vomiting, 84%. Text. Slide 6. What would you do, table or text? Diarrhea was the most common symptom among cases, 92% at function A, 77% at function B, followed by nausea, 84% and 69%, vomiting, 84% and 69%, stomachache, 65% and 72%, and headache, 25% and 45%. Slide 7. You would need a table. Look this table. Slide 8. The tables should be self-explanatory. Title should clearly express information about person, place and time of study. Table should be self-explanatory. Reader should be able to understand table without reading the text. Rows and columns should be clearly labeled, include totals if appropriate. Footnotes to table should include sources of data, and abbreviations and symbols, clarifications, explanation of p-values used for significance. Slide 9. Check and recheck all numbers in tables. Proofread carefully for transcription errors. Arithmetic errors may cast doubt on your results, so carefully check all arithmetic in table, check that rows and columns add up correctly, and check that percentage is correctly calculated. Slide 10. Can you summarize the information in the table? Make suggestions on how to improve it. Slide 11. How we improved the table. Title should specify exactly what is being reported, such as incidence or prevalence, and provide information on time and place data, when, what and where. Total column would be useful. You might want to also include columns with percentages for each disease. Slide 12. Can you summarize the information in the table? Make suggestions on how to improve it. Slide 13. How we improved the table. Percent column adds up to more than 100%. Correct error or indicate why column does not sum to 100%. Include the total number of cases in the title. Slide 14. Is this the best way to present this information? From January 13 to May 28, 2010, a total of 581 patients with available medical records were admitted to the Port-au-Prince Field Hospital, Haiti, with an injury diagnosis. Of these, 162 had earthquake-related injuries. Among all injured patients, 333 were male, 236 were female and 12 were unknown. Among earthquake-related injured patients, 74 were male, 85 were female and 3 were unknown. Slide 15. You can identify key information in the text. We have highlighted the relevant information. Slide 16. In the very simplest terms, a table is a set of data that is organized into rows and columns. The boxes within the table that contain data are called cells. Usually, and particularly in epidemiology, these cells contain quantitative data. Each row and column in a table should have corresponding labels that are clear and concise. In most simple tables, the categories should include all values that the variable can take. Note that the sex variable has category labels male, female, and it even has an unknown category. Each row and column should be accompanied by totals. Include a row or column for unknown or missing values, if needed. A successfully and correctly structured table, particularly one for a written report or scientific manuscript, should be self-explanatory, meaning that it is easily understandable and capable of standing alone. The tile should describe the what, topic, where, and when. So the table should make sense when viewed all by itself, independent of the report or manuscript to which it pertains. If any codes, abbreviations, symbols, exclusions, or data sources are used, these should always be explained by a footnote. Slide 17. How can you have a good design of graphs, figures, charts, and maps? You must display complex data in a compact and understandable way. It allows reader to see patterns and trends in the data. It shows relationships in the data. Slide 18. What is usually included in graphs? Display quantitative data using a set of coordinates. Rectangular graphs, x, y coordinates, most common. X-axis along bottom equals method of classification, often time. Y-axis alongside equals frequency, usually number, percent or rate. Slide 19. A good graph has title with what, where, and when. It includes units of measurement, years, mg, dl, etc. for each axis. It avoids 3D, too many colors and other unneeded clutter. Design them to show relationships you want to highlight. Select an appropriate graph type. Slide 20. For making a line graph, make x-axis longer than y-axis, best ratio 5:3. X-axis, match x-axis scale to intervals used during data collection. Y-axis, always start y-axis with 0, identify largest value, round up for maximum y value, and select reasonable intervals for y-axis. Plot data. Create title. Add comments, footnotes. Slide 21. It is an example of trends of measles by year. You can remark vaccine introduction. Slide 22. How can you improve it? Slide 23. You need to avoid 3D, too many colors and other unneeded clutter. Slide 24. Vote on which one they prefer and why. Compare with the last graph. Slide 25. Maps also useful to show where your study is located. Maps can visually display geographically referenced epidemiological data such as distribution of epidemiologic variables over geographic areas. Changes in distribution over time, if you have maps at several points in time. How relationships and associations vary over geographic areas. Slide 26. These maps show the mortality for those aged under 5 for 1990 in the top map, and 2009 in the bottom map. The darker the red, the higher the mortality, so you can see that between the 2 decades, there has been a reduction in the number of red countries, which means a reduction in the mortality for those aged under 5 over the 20-year period. Slide 27. Color-shaded maps can mislead. Color-shaded maps have only one color for each geographic area, for example whole country. They cannot display variation within geographic areas. For example, world maps shown in previous chart do not display differences within countries. Slide 28. This shows the number of current probable cases of SARS as of June 24, 2003, and again the darker the color the more cases. However, this map has the addition of the labels with the number of cases per country, which makes it easier to interpret. However, you still have the issue of coloring whole geographical areas. For example, all of Brazil and all of Russia are shaded, even though they only had 1 case each. Slide 29. Using dots is another way to show data on maps. This allows for more targeted geographical representation. Here, the larger the dots, the higher the seropositivity for HIV among injecting drug users. Slide 30. What conclusion would you draw about the epicenter of hepatitis A based on this map of districts in Mongolia? Here it looks like the epicenter is the Chenjeltai district, slide 31. Here it looks like the center is in the Bayangal district, although it spreads out all around this district too. Slide 32. You can include in a bulletin, graphs, maps and tables. It allows to improve information dissemination.